as a result of the construction of the project. In order to develop those numbers, I'm going to refer to one of the standards I had mentioned at the outset of my presentation. The Institute of Transportation Engineers publishes information that allow traffic engineers and transportation planners to establish traffic volumes for any type of development project, be it residential projects, commercial projects. In this case, there is statistics that are available for the amount of traffic you would expect an apartment community to generate. That information is published based on the number of units. So if you know the number of residential units that are to be constructed within the development, you can go and look at the Institute of Transportation Engineers data and develop traffic volume information for the project. So in this case, for a 90-unit residential apartment community, the applicant has used the appropriate sources, developed the traffic volumes of the project, and based on those industry standards, the expectation is that this project will generate 670 vehicle trips on an average weekday. That number, as I speak of vehicle trips, it's two-way traffic, so that's half of those vehicles will be going in, half of those would be going out over the course of a 24-hour period on a weekday. And what's important to recognize in that number as well, it's not just the residents of the project. This would be any traffic that would be associated with service to a residential development. So it's UPS, FedEx, it's trash, recycling, it's any type of vehicle you would need to service a residential development in addition to the residents of the project itself. During the peak hours, so during the weekday morning peak hour when people are going to be going to work, so the highest traffic volume hour between 7 and 9 in the morning, the applicant projects that the project will generate 48 additional vehicle trips. It's 10 vehicles will be entering, the majority in the morning will be exiting, that's 38 vehicles. In the evening, the highest traffic volume hour between 4 and 6, the project is expected to generate 68 vehicle trips, and that will be 44 entering and 24 exiting. It's very often that a question is asked, if it's 90 units, wouldn't it be 90 coming, 90 vehicles at least leaving in the morning, and the same thing in the evening? Wouldn't there be at least 90 coming back if you assume one vehicle per unit? What's important to recognize is we're speaking of peak hours, and so I always describe it as the fact that your neighbor may not leave to go to work at the same time that you do. Sometimes I'm out the door at 5:30 in the morning, my neighbor may be leaving at 7, and so we're not all leaving at the same time. But what these numbers represent is during the absolute peak hour, so the peak traffic volume hour for the project, at the same time that the roadway peak is going to happen, this is the volume of traffic you would have. And I had mentioned that we want to make sure we're analyzing worst case conditions. So the worst case condition is the peak of the project added to the peak of the roadway, and that's what these numbers represent. Once that volume of traffic is generated, the next thing is to look at is how is that traffic going to relate to the roadway network itself. So it comes out to the driveway, and now we need to estimate how much of that traffic is going to turn right or left. And the same thing is it's coming back in the evening, how much of it is going to come up Randolph Avenue from the north and how much from the south, and is it making a left or right-hand turn coming into the project. There's a couple of ways to do that. The first way is to look at existing traffic patterns. So if you assume that the majority of the traffic on Randolph Avenue during the peak hours is commuter traffic, this being a residential project, there's an expectation that the traffic patterns should generally follow the same traffic patterns that are on the roadway today. The other way to look at it is using U.S. Census data. So as each of us fill out our census forms, one of the things that we report is where we live and where we work, and how we get to work. That information is published through the census. It's available to us as traffic engineers as well. So we can look at, in particular, the town of Milton, look at, for the residents of the town of Milton, as you report on your census form, where do you go to, where do you work? And in using that information, you can generally look at from any point within the town, once you know where residents live and where they go to work, then you can look at the transportation system and see, well, okay, between point A and point B, what is the quickest way to get there by using the roadway network? It's there. You can then take that information related to the traffic volumes on the roadway and come up with a distribution of traffic. In our review of the applicant's distribution of traffic, if you look at the way the traffic study is constructed, one of the things that jumped out at us is that we typically, for a residential project, if you say 50% of the, or 60% of the traffic goes north in the morning, you expect that same volume of traffic to come back in the same direction in the evening. In looking at the way the traffic study was done, that's not the traffic pattern that was used. There's what we had noted, and again, we've suggested the applicant needs to explain this. There's a significant difference in the way the traffic uses the roadway network in the morning that they've expected for the residents, then comes home in the evening. The patterns are significantly different, and we've asked for them to explain that because that's not expected. We don't expect to see that for a residential project. Generally, people follow the same travel routes. So we've asked them to explain that. We've also asked them to do that two-step approach. We've asked them to use the census data, then look at the roadway network and come up with some travel and tell us what that data would suggest to you the trip patterns are. Because again, if we saw similar traffic patterns leaving in the morning, coming back in the evening, we may suggest that they do that homework and looking at the census data as well, but we kind of would expect a similar pattern. But in this case, because it was significantly different, it needs to be explained. And we've asked them to take it to the next step as well as to look at the census data. That's important because, as you mentioned, probably the most difficult move to make coming out of the project, and this is not uncommon of any driveway or roadway along Randolph Avenue, is the left turn. So we need to understand that. But it also has to do with the impacts at the intersections. If more traffic is going north and south, it's going to have a different impact on different intersections. So it's important that we understand and get that measure of the distribution of traffic correct as well, so that we can assess the impacts of the project. And similar to the no-build condition, again, we've suggested when they develop the build condition, so this is adding the project's traffic to the roadway network, we want to be looking at that 7-year planning horizon as well, so we can do that comparative analysis. So once all of these traffic numbers have been developed and they've been added onto the roadway network, the next thing that's done is assessing impacts. And the way that it is done, it's known as a traffic operations analysis. The applicant has done that, of course, with all of these things we just mentioned that we want them to go back and look at. They're going to need to redo all of that analysis. But I'll just mention what they had done as a part of the analysis in the traffic study. Again, traffic operations analysis, what they're looking at, and what we're looking at as transportation professionals at intersections is we're measuring a few things. It's motorist delays at those intersections, and those delays translate into vehicle queuing at the intersections. And those two parameters are reported based on what's known as a level of service. And a level of service you may have heard presented to you before. It's just like a report card that you get in school. They're reported A through F, with A being generally good operating conditions, F being considered failing conditions. Those letter grades are correlated to delays, and the delays are essentially, an A would be representative of, like, on average, a 10-second delay. So if you came up to a stop sign, you want to make a left or right-hand turn. If it's an A condition, that means you generally would wait about 10 seconds. There would be a gap in traffic. You could complete your turning maneuver. And F, which is considered failing conditions, that means you wait a minute or more on average at a location. And it's generally characterized by long backups as well. So if you have a failing condition, what you'd often see is a big line, long line of queues. And if you're at a traffic signal, what it often means is you'll wait more than one light cycle to get through. You just can't get through on that green light. You get up to the stop line, you got to wait another light cycle to get through there. So that would be a characteristic of a failing condition at a location. The state generally defines a level of service or a grade of D or better being the limit of acceptable traffic operations. And so that gradation of a D would mean about 35 seconds on average of delay at an intersection. So that's considered acceptable operating conditions at a location. So as the applicant went through and did their traffic operations analysis at the signalized intersections that they looked at the Randolph Avenue, Reedsdale Road, and the Randolph Avenue, Reed Street intersections, during the morning peak hours, both of those intersections were graded F. They're failing. And those level of service of F translated into extended queuing on those approaches there. So given the volume of traffic, not unexpected on those roadways. So that's essentially the condition they're starting with. The intersections today are under failing condition. So of course, absent improvement, as you look in the future, they're not going to get any better. They didn't, as I mentioned, they need to do some research as to see if improvements are planned at those locations. But given what's in the study right now, today they're at a failing condition. So absent improvement, they're going to continue to be that way in the future, independent of the project itself. In the evening time period, what was noted at the Reedsdale Road intersection that continued to fail, but there was a noted improvement at the Reed Street intersection. That one was shown to be at an overall level of service of B at that location itself and during the evening peak hour. And again, that happened under all analysis conditions, the existing, the no build, and the build conditions. One of the things that the applicant did do in their traffic analysis is they did suggest, as a part of the analysis, they suggested some improvements, although those didn't show up in the recommendation section. They've suggested that to accommodate the additional traffic from the project, that there would be some adjustments to the traffic signal timing at both of those intersections, and that with those adjustments, although you would still have those level of service F conditions, the failing conditions, they were able to show that they were able to create sufficient capacity so that they would create what's known as a no harm condition. So if they add 5, 10 cars to the intersection during the peak hours, with the adjustments to the signal timing, they can get those 5 or 10 cars through the intersection over the course of the hour so that your delays didn't go up substantially and your queues didn't increase substantially. But again, if that's in fact the case as they do their subsequent analysis that we've suggested, that needs to be a commitment from the applicant of mitigation at those intersections, because they've said that that's something they need to address the impact of the project at those locations. So as we talk about it, eventually potentially having conditions relating to the project, that would need to be a list of conditions related to traffic operations that they would in fact agree to make those improvements at those intersections. We have asked that when they do go back and revisit the analysis and the traffic volumes, what they did present to us, they presented existing traffic operations, the no-build traffic operations, and then essentially build traffic operations with the mitigation. We didn't see, they didn't present to us an analysis of basically build conditions with no mitigation. We do want to see that analysis so that when they do in fact go to the next condition, which is the build with mitigation, we need to be able to see, first of all, the comparison of the no build to the build, what the impact is, and then how much of an improvement is gained by going to the mitigated condition. So they have to show us existing, no build, build without mitigation, and then build with mitigation, so that then both ourselves as well as you as the board and the public can see what level of improvement is attained as a result of the mitigation. The next part of our review dealt with the site distances, and as I mentioned, kind of the critical element with respect to the 40B project, but all projects in particular, is safety. With respect to the access, site distance is probably one of the most important issues relative to safety as to how the intersection itself is going to operate, and that we, in fact, can make a finding to you that the access is safe and adequate to accommodate the project. So there's two types of site distances that are measured at any intersection. The first is what's known as stopping site distance. Now, the stopping site distance is the site distance that if you're a motorist and you're driving along Randolph Avenue, it's the distance that you would need to be able to see a 2-foot object in the roadway. Now, that 2-foot object is defined as that object, or that object height, is something that as a motorist you would need to make a decision: am I going to drive over this object, or am I going to apply the brakes and stop? As soon as you get an object above that, it's something that would physically damage your vehicle, so you would make an avoidance maneuver in that case. But that 2-foot object is determined to be a critical decision-making object in the roadway that you need to be able to see and safely make a decision to stop your vehicle. So your stopping site distance is the site distance a motorist traveling along Randolph Avenue would need to be able to see a 2-foot object in the roadway if it's traveling at that 85th percentile speed. So if you're going 46 miles an hour, there's a certain distance you need to be able to see that 2-foot object in the roadway, see it, perceive it, apply the brakes, and physically stop the vehicle. So that's the first measurement that's made. And that measurement is made assuming that 2-foot object is at the point of the driveway. So it's in the middle of Randolph Avenue or in the travel lane, and it's at where the driveway is located. The second sight distance is known as intersection sight distance, and this is one of the probably the more common sight distances that people are familiar with. And this is if you're coming out of the development and you're looking to the left or right as the motor's exiting, this is the sight distance you would need to be able to see a vehicle that's approaching you on Randolph Avenue at that 85th percentile speed. So it's approaching you at 46 miles an hour. You're coming out of the vehicle, out of the project, you're stopped at the stop sign. You need to be able to see that vehicle and make a decision as to whether it's safe to pull out of the project and make a left or right-hand turn. So the applicant has assessed both of those sight distances. What they've done in the traffic study is they've indicated they've assessed those, and then they've provided the distances, and they've also, that are required, and then they've just indicated yes or no whether they've met those sight distances. But they didn't report what the actual measured distance is. We need to have those distances so we can assess whether it does in fact meet the requirements. We're not saying that it doesn't, but we do need that data in order to substantiate their conclusion that they do in fact meet those distances. We've provided, as I mentioned, guidance to the applicant as they're looking at the sight distances, although they gave us what the minimum requirements are for 46 miles an hour. Because Randolph Avenue is it's a 4-lane roadway, 2 lanes in each direction, the sight distances need to be adjusted to account for the fact that a vehicle that in particular is making a left-hand turn, it needs to cross 2 travel lanes and get into a 3rd travel lane at a minimum when they're exiting the property. The way that they've done the sight distances in the traffic study is they didn't make that adjustment to increase the travel time that's required to cross multiple lanes of traffic. So they do need to go back and adjust the measurements. They'll actually need to be increased in terms of the sight lines that are required. You need longer sight distances to cross more lanes of traffic. So they need to make those adjustments to reflect that fact. The other thing that they did as a part of their adjustments, the way the sight distance standards are published is the distances that are published assume grades of the approach grade on the roadway. If you have grades that are 3% or less, they tend not to affect the sight distance measurements so that the published values are acceptable and you can just use those. If you are at grades above 3%, you similarly need to apply an adjustment because the braking characteristics of vehicles on grades that are more than 3% are different, and you need to apply adjustment factors to either increase them if it's on a crest curve or decrease them if it's on a sag curve. They've applied adjustments indicating that the road is at a 2.5% grade. So that's below 3%, so you don't apply an adjustment factor. You just use the published values. So what we've said is they need to go back and reassess the sight lines, they need to physically provide us what was measured. They need to apply a correction factor to account for the fact that it's a multi-lane highway, reevaluate it, and then provide that information to us. We did note, we did try to go out and perform a site visit and look at sight distances on our own. Unfortunately, given the conditions that were out there, you could not do that safely. There's just no way today to go out there. First of all, there's no place to park a vehicle. Second of all, there's no place to safely observe sight lines, just given the fact that you can't even stand, the sidewalk has snow on it. You can't physically get out there and measure sight distances today just because of the conditions that are there. So we weren't able to verify whether they did or did not meet any of the standards. There was nothing that jumped out at us to suggest that there's a sight line restriction, but we do need to get their measurements so that we can take a look at that. The only thing of note is that as we talk about that stopping sight distance, so along Randolph Avenue, is that as you head north of the site, there is a slight crest vertical curve that's there. It may not look imposing as your motorist driving along the roadway, but it's surprising at how much a little bit of variation you can lose that 2-foot object pretty quickly. And especially if you're traveling at 46 miles an hour, as you look at that in feet per second, you can come upon that object very quickly. And so, again, that's why we want to see exactly what they had measured and just verify that. The last thing that we looked at relative to the traffic study was specific recommendations. as a transportation professional or traffic engineer looking at any project, there's always recommendations that you're going to have. And they may be things just simply related to the site plan in terms of the way that the site driveway should be designed, the traffic control features that should be there to control traffic. As we looked at the recommendations in the traffic study, there weren't any. And so we've provided some suggestions that the applicant should look at. As they read through these, a lot of them may be already a part of the site plan, but just from the standpoint of prudence in looking at it, we've provided some recommendations, and I will go through those with you. The first thing is really, it deals with the traffic signal timing adjustments that were recommended. That was a part of the traffic analysis, although it didn't show up as recommendations in the recommendations section of the traffic study. So if the applicant is relying upon those improvements to demonstrate sufficient capacity, then that needs to be a recommendation and a commitment from the applicant. And so that as you're writing conditions, you also have that as a part of the public record, that they agree to do that, and that their analysis is in fact based on the fact that they're able to make those improvements. The next series of recommendations that we've listed that suggested for the applicant do deal with the way that the driveway is designed. So the first thing is minimum performance standards relative to the driveway. And again, these may be a part of the site plan. The driveway should be a minimum of 24 feet in width. As traffic gets to Randolph Avenue, it should be, I think we talked about the fact that it needs to be under stop sign control. So there physically needs to be a stop sign there, and then that stop line, so that painted white line, needs to be provided as well. Sidewalk along at least one side of the project site driveway. I believe that they do have that as a part of the site plan itself. That driveway or the sidewalk should connect between the project itself, so the buildings, the site plan, and we'll get to our suggestions on the site plan as well. What we do want to see is a continuous pedestrian facility from the buildings along the driveway out to Randolph Avenue, because we know that there's sidewalks there. So there needs to be connectivity between all of those uses themselves. At the driveway, as well as internal to the project site, there needs to be wheelchair ramps for crossing the driveway. They need to be accessible, so they need to be ADA compliant. And then we also would like to see a crosswalk, physically striped crosswalk across the driveway, as well as any place internal to the site where the pedestrians will be crossing the traveled way. Given that this is a residential project and there may be school children living there, there does need to be provisions for a school bus waiting area. We're not suggesting that needs to be a bus shelter, but there needs to be accommodations, and that should be so designated on the site plan. They should also consult with the school department to find out what is an acceptable accommodation for the school department. It's very often that they will not run or have school buses traverse internal to projects because just for liability reasons. So that means that out on Randolph Avenue, there needs to be an area where it's acceptable to the school department, where they will pick up children. And the site plan should designate it, and we would want to take a look at that and make sure that it's safe, that it has a curb that's protecting where children and pedestrians may be waiting to be picked up by the school bus. Standards in terms of internal to the site, we've suggested or would actually recommend that there be a note on the site plan indicating that all signs and pavement markings to be installed within the project site need to comply with the manual on uniform traffic control devices. That is a standard. The reason that that's recommended is because what you don't want to have is signs and pavement markings within the site that are not typical of what a motorist would expect. And so the expectation is that the same type of traffic control devices, signs, pavement markings that you experience when you're driving outside of the site should be the same thing that you have internal to the site. So that deals with types of signs, sizes of signs, type of pavement markings, the color of those pavement markings. They should all be standard so that there's no difference between the off-site and what you have on-site. Getting back to the sightline parameters, one of the things that's important as the site plan is developed and they look at landscaping features is we want to make sure that there's nothing that's designed both internal to the project site as well as external at Randolph Avenue that would inhibit sight lines. So if we come to the conclusion that there's adequate sight lines out there today, we want to make sure that as the site plan's developed that there's no walls, decorative features, plantings or such that would inhibit those sight lines. But also to go a step further, we need to accommodate snow. And so very often what you see under the conditions that we've experienced this winter is that snow gets piled up on top of these features or adjacent to driveways, and they block your sight lines. So to try to deal with that type of condition, the first thing is that if there are plantings, features that will be placed within those sight triangle areas at the driveway, they need to be at least 2.5 feet below the surface elevation of the roadway. So basically, if you take the surface elevation of the driveway, any plantings or features that would be adjacent to the driveway, they should be no higher than 2.5 feet, and that allows us to have a foot of snow accumulation on top of that, because the way the sight distance measurements are done, it assumes that the driver, their eyes are 3.5 feet above the pavement surface. So if you have no object higher than 2.5 feet, then that means you can have a foot of snow on top of that, and you could still actually see coming out of the driveway. So the 2.5 foot is a critical dimension for sighting heights of objects. The other thing is those what is known as snow windrows. So as the plows go down the street or the plows plow the driveway and it piles the snow off to the side, similarly, you don't want those piles to accumulate at a height more than 2.5 feet. Now they will after the snowstorm, but as a condition of approval, what we've always suggested in projects is as soon as the snow piles get more than 2.5 feet, as soon as practicable, the applicant should be required to remove those snow windrows so that the snow, that the sight lines are maintained at the driveway. So that we would suggest that if you're so inclined, that would be a condition of the approval of the project, that they would be required to remove snow promptly when it exceeds 2.5 feet in height. Internal to the project site, one of the things we'd like to see noted on the site plan is a bicycle rack. And that residential projects, at a minimum, we would suggest that it be provided where the clubhouse amenities or leasing offices, that you would have an exterior bicycle rack. They may be providing bicycle accommodations internal to the garage. That's also a good thing to have as well. But it's also often that residents will bring their bikes up to their units, depending on the type of project. But at a minimum, we'd like to see at least one bicycle rack out near the clubhouse amenities leasing office area. The other thing is when the applicant comes back and looking at the pedestrian and bicycle facilities and public transportation, we've also suggested that because we know that those amenities are out there, they develop as a part of the project a transportation demand management program, and this is typical. You'd have this type of a program where you have public transportation access, and what this is basically just it's a program or a series of things that the applicant agrees to do to try to minimize the amount of traffic that's associated with the project. Some people view this as an onerous criteria. It's not really. What it really means is that in the management leasing office, you provide information to the residents that may want to use public transportation. You post the schedules there or somehow make them available to the residents. So if they want to ride the MBTA bus service that's available along Randolph Avenue, the schedule's there. They have a way to find that information. So it's just making things available to the residents if they so choose to use public transportation. In the leasing office, it's there and available to them. It also can be on the website for the project. So there's a lot of ways to be able to provide this information that's not onerous on the applicant, or it was really something that increases cost related to the project. That is really our review of the traffic study. The next set of review deals with the site plan itself, and as I mentioned, there is some overlap between what Mr. Turner had reviewed, although our focus more deals with access and circulation. The first item relative to the site plans, and probably this is one of the more important things that I think the applicant should look at kind of coming away from the meeting tonight. And this does deal with life safety access to the project. And I did note this in the recent response to comments letter that the applicant had submitted, because I think this was raised by Public Works as well. And I think you asked Mr. Turner the same question. From the standpoint of life safety, we do look at a couple of things. The first is the emergency vehicle access to the property. Can it get in and out of the property, and can it circulate adequately as well? But another criteria comes down to, in terms of sufficiency of life safety access, is a secondary means of access. So as we look at it as transportation professionals, there is guidance that's provided relative to the need for secondary access, and this deals not only with access by way of driveways, it also deals with dead-end streets. And so a lot of times what you'll see in a community is that they'll limit the length of a dead-end street or limit the number of residential units that can be accessed by way of a dead-end street. And the reason for that is it deals with the fact of the potential, and it really comes down to statistics. What is the potential or probability of an emergency situation happening, the need to respond to that emergency situation, and the adequacy of providing that response? And so the number of residences that are served by either a driveway or a dead-end street deals with those statistics. The more residences that you have accessed by means of a single driveway or by way of a dead-end street, there's more potential for there to be an emergency situation that you need to respond to. So the guidance that's provided by way of the Institute of Transportation Engineers is twofold. It suggests that a dead-end street should be no longer than 1,000 feet, and that dead-end street should serve no more than 30 dwelling units. So you look at those two criteria, and as we apply that to the project itself, although the driveway itself, if we look at that as saying it's not necessarily a dead-end street, but there's no other way to get in and out of this property other than the single point of access. It's not more than 1,000 feet, but it does serve more than 30 dwelling units. So there's 90 dwelling units. So as we look at that guidance, what that says to us is there needs to be a secondary means of access for life safety. It's not required from the standpoint of adequacy of access for the residents, but from a life safety perspective, given the number of units that are there, a secondary means of access is something that's highly recommended. And in terms of the guidance that's provided, we're suggesting that needs to be demonstrated for the project. Now, secondary access can be made by two means. The first is a separate and distinct means of access. So you would have another driveway or another connection. The connection, as I mentioned, does not have to be for the residents, but you could have a gated connection from another point, and that point needs to be physically separated for some distance from the physical driveway for the residents in the project. And the reason for that is it's really, if one means of access is blocked, there's a secondary means of access to come in, and that's why they need to be separated by a certain distance.
Is there a minimum distance
It's
that's
typically,
customarily?
it's customarily about 200 feet is usually what the separation is.
Thank you.
That can't always be provided for projects. And Mr. Turner mentioned the same thing in terms of his review, and you had asked him the question of, I think the same line of question is it typical, or in your experience as you're designing sites, can you provide a similar level of access? And the answer is no, you can't always do that. The other way that the secondary means of access can be achieved is what's known as a boulevard type treatment. So just as was described, if you can't provide a separate, distinct means of access, you can design your driveway as a boulevard, and so that you'd have entering lane and exiting lane. Those two lanes are separated by a median. And that median is designed to be traversable by emergency vehicle. So that what you would have is basically, we describe it as you'd have sloped curbing on either side, either granite curb or concrete curb, whatever it happens to be. But that the emergency vehicle, if it comes in the entrance and at some point the entrance is blocked by either a broken down vehicle or an object that's in the roadway, the emergency vehicle then can drive over the top of the median and comes on the exit side, it can still get into the project. So having a boulevard type treatment satisfies the standard of a secondary means of access just because it's traversable. Again, it's that key phrase of traversable. So if the applicant looks at designing a boulevard type driveway, we would be looking at those features to make sure that it is traversable. That you could do plantings along it, but the plantings, you want to make sure that they're either regularly spaced so that a vehicle could actually get between them, or you could physically do breaks in the median where the emergency vehicle could travel through or through a break in the median to get to the other side if it needs to.
But based on Mr. Turner's testimony, do you foresee that would result in environmental issues for the applicant? Because to build the type of boulevard that you're requesting, or you're saying is an alternative, would necessarily require more disturbance of the wetlands, and they're very close to the 5,000 square foot limitation.
Well, depending on how close the wetlands are to the road, I mean, the applicant may be able to do it with retaining walls or such to be able to minimize the disturbance that's there. I'm not that familiar with how much they're impacting the wetlands or where exactly it's happening. I would also suggest, and again, the applicant needs to go back and look at this. It doesn't mean that the boulevard needs to extend the entire length of the driveway. I have worked on projects where we have wetlands crossings and constraints similar to what is happening here. I know they've got at least one crossing that's taking place. The boulevard should at least extend to the point where that crossing is. And, you know, not my responsibility to design it for the applicant, but I would offer that as guidance that at least if the boulevard got them to the point of the wetland crossing, then they've gotten far enough into the project site where the emergency vehicle more or less could traverse probably the rest of the way into the property. But at least that first distance would be acceptable because the majority of where your blockages are going to happen or where accidents may happen for motor vehicles are going to be as you get closer to Randolph Avenue. That's where that type of activity or blockage is probably more apt to take place. So at least if they got it up to the point of the wetland area, that may be something that's acceptable, but we need to see what they would propose for that.
Great, thank you very much.
I think that's probably the most critical thing relative to the site plans that needs to be looked at from our perspective. Sightlines important, but also the adequacy of the access and the adequacy for life safety needs to be demonstrated. And this is probably one of the key areas in looking at the access into the property. Again, relative to the driveway, Mr. Turner had mentioned the grades on the property. What we look at relative to the driveway itself is that as you're approaching Randolph Avenue, the grade of the driveway, it should not exceed 2%. It could be positive 2% or negative 2%, but the driveway should be the grade should be no more than 2% within 50 feet of Randolph Avenue. That is relative to drainage, so that we're not shedding drainage out onto the state highway, where you could potentially have icing conditions. But I think more importantly, as we're looking at sight distances, you want to have a leveling area. So as the vehicle is coming out to Randolph Avenue, it has a leveling area that's fairly level to stop, but that's also critical for sight distances. If you have grades that are starting to exceed that, that will affect your sight distance and would need to be entered into their calculations. The next area that we had looked at, again, deals with the emergency vehicles, but just general vehicles as they're circulating within the project. The applicant did provide a turning analysis as a part of the site plans and as a part of the response to comments that was submitted. We did review that, and we've suggested that they need to go back and revise that, and we've provided guidance on what we're expecting to see in the revised turning analysis. The first thing is we looked at the turning analysis that was done. If you look at the physical positions of the vehicle starts, he's already on the driveway, and then he goes into the site, and then he comes back out. But what we have to see is, can the vehicle physically make the turn from Randolph Avenue into the driveway? And then similarly, when it's coming out, is it able to make a right-hand turn as well? That was not shown on the analysis. All we basically saw was the vehicle can drive up the driveway and get into the site, and then it exits.
Does it exit by turning around and using a
Well, that wasn't clear either. What you see,
back out?
we've said to them, they need to tell us what that vehicle's doing. Because from the standpoint of the turning analysis that was provided, it's almost as if you pick the vehicle up and you dropped it on the driveway and then it drives in, and then you picked it up and turned it around and then it comes back out. We can't, it's got to show the full range of movements. In order to adequately analyze it, you show it turning in, going in, and then we see the same reverse maneuver from where it stopped after it comes in. We need to see, does it back up and then come back out? You need to see the full range of motion, and that's not shown on the exhibits. So we can presume what it's doing, but I don't want to presume that. I want them to show us how they're assuming the fire vehicle, trash vehicle, recycling vehicle, how it gets in, how it gets out, the maneuvers that are required in the site, because we wouldn't be able to say, demonstrate, or make an opinion to you as to adequacy without seeing all of that. So they need to do that. And again, we provided guidance to them on what we're expecting to see. In terms of the fire department vehicle, one of the things that's often overlooked, and I'm not familiar with the town's fire apparatus, and the fire chief can comment on this. when the turning analysis is done, what you see is you not only see the vehicle, but you'll also see the wheel patterns, so the physical tracking of the wheels. The important thing sometimes that's overlooked for the fire department vehicle is beyond the wheels and beyond the front, if there's the aerial basket, that overhangs the front of the vehicle, and that's not always shown on the swept path of the turning analysis. It's important we see that because as we look at that swept path, if that ladder area is swinging over the sidewalks, we need to see that because as they're placing their light poles, that will interfere with that. So they may not have got into the lighting design, but that swept path and looking at those overhangs, both the front overhang and the rear overhang, are going to provide some guidance to say you can't place certain things within these areas. And so they either need to widen the road to make sure that those are kept clear, or as they're going to design the landscaping, design the lighting, that they acknowledge the fact that there shall be placed no objects within those swept path areas. So that has to be added to the turning analysis. As well as you had mentioned, if there's backup maneuvers, that needs to be labeled on the turning diagram so that we know from the point of the stop where they enter that there's a backup maneuver required to exit and exactly how that's going to happen. In terms of trash and recycling, I think they did answer this as a part of their response, recently submitted response to comments. As I understand it, and we just asked them to clarify that, trash and recycling will be stored within the buildings and they will be rolled out of the garage areas, and that will then be picked up on the outside area. So what we need to see as they're doing the turning analysis is where that is happening and demonstrate the vehicle can get there, that when those containers are pushed out and put in those areas, that it's not interfering with the flow of traffic within the site or being able to enter or exit the garage. The same would apply for moving vehicles. We didn't see anywhere in the site plan where it's designated the moving areas. That's going to be important in looking at the turning analysis, but also in dealing with parking. If there's an intent that parking spaces will be designated for move in, move out, if they're going to cone off those spaces, then your parking supply goes down. So we need to know how are they managing the move in and move out, where's that going to happen, and then when they're doing the turning analysis, wherever they've identified these locations, the turning analysis needs to reflect the vehicles getting to those areas. The next areas that we provided are recommendations relative to the design of the parking spaces themselves and circulating aisles. When you have 90-degree parking, the circulating aisles need to be 24 feet in width. So we believe that that's the case, but we want to see dimensions, or at least the applicant acknowledging that all aisles, all travel aisles within the site are going to be 24 feet where there's 90-degree parking. We provided recommendations on the design of the parking spaces. We didn't see a typical parking space design, but they may be 9 by 18, but we just need to verify that. We did note the handicap spaces are 8.5 feet wide, which is acceptable, but we do want to see typical parking space dimensions. They do have a parallel parking space. That parking space, we've suggested it needs to be 8.5 feet by 22 feet long. That's a critical dimension for maneuvering. At this point, it's not. I think they can modify it, but it does need to be modified. It's not 22 feet long, so it's difficult to maneuver into and out of at the reduced dimension they provided. We've just indicated that the applicant consider providing electric vehicle charging stations. Not a requirement. Again, it's just something that, as good planning practices for project, at least provide the opportunity for that to happen in the future, because we do recognize there is a cost associated with doing that on the applicant. And again, the last thing in terms of the site plan is the tenant move-in and move-out plan. We just need to understand how that's going to take place, because it affects access and circulation as well as the parking supply. The last thing in our review did deal with the parking, and in this case, relative, not so much the design, but the adequacy of parking in terms of the number of spaces that are provided. So the applicant has proposed for 90 units. They're going to provide 156 parking spaces, consisting of 83 located beneath the two buildings and the garages, and then they're going to have 73 surface parking spaces. That results in a parking ratio at 90 units of 1.7 spaces per residential unit. I believe the applicant is requesting a waiver from the town's parking standards relative to 2 spaces per unit. So what we're doing in terms of our review on parking, in this case, in looking at adequacy, is just to see is 1.7 spaces adequate to service a residential development of this size in the location that it's proposed, so with similar access to public transportation and such amenities. So we do have information similar to, as I mentioned, about generating traffic. The Institute of Transportation Engineers also publishes standards relative to parking for residential developments, and they do have information on what would be expected at a residential apartment community. And what they've indicated in terms of their standards is that in suburban settings, if you have limited access to public transportation, they've documented average parking demand of about 1.23 spaces per dwelling unit. The 85th percentile parking demand, and that's typically what we design to. And again, this is in a suburban location with limited access to public transportation. The parking ratio that they've suggested, a parking demand, is 1.94. Now, if we look at apartments in urban locations, similar to the location where this project is proposed, the average parking demand is about 1.2. I would suggest that's very low. The 85th percentile parking demand is 1.6. In looking at these standards and looking at them in relation to the project and the environment in which it's located, the 1.7 spaces we've suggested, it's within the range of the industry standards. It's within the range of what we as traffic engineers in this area typically see at projects. We've seen them parking demands as low as 1.5. 1.6 is more typical in an urban area, and so the 1.7 spaces per dwelling unit, I think, is pretty standard. And we're comfortable with that, suggesting that that parking ratio would be sufficient to accommodate the demands of the project. It's consistent with industry standards, and it's also consistent with what we see in kind of the Metro Boston area in terms of parking demands as you get outside of kind of the city proper area. But again, the caveat on that really goes with making sure that all these other things we had mentioned, the vehicle turning analysis, the parking space size, all of those are demonstrated to be adequate, because if we do find that for some reason they need to use some of the parking spaces for move in, move out, or that we have vehicles that require the use of those spaces to back out or to maneuver, then the parking supply, the effective parking supply, is actually reduced. And so 1.7 is adequate, predicated upon them demonstrating that there are no other issues relative to access and circulation within the property. That concludes our review of everything that's been submitted to date. And again, I believe it encompasses everything up to the last response to comments letter as well.
So, I want to thank you for a very, very detailed and comprehensive analysis and review. I obviously don't have a lot of experience with traffic engineering, but it shows you how technical and detailed an analysis has to be on all of the factors in order to get a good end result. And I think you did a wonderful job making that presentation. It's now 10:40. We usually adjourn our meetings at 10:30 because people tend to get tired and sleepy. Let me just inquire of the board members if they have a significant amount of questions and see if we should be adjourning at the present time or push on for just a very few more minutes. Mr. Caggiano may have clients at 9 o'clock in the morning. I hope you don't, Alan, but that's always a factor. Mr. Mullen, do you have a significant number of questions?
I have one question.
One question. How about you, Mrs. King?
I have none.
Do you want to proceed cautiously? Do you have to leave within the next 10 or 15 minutes?
This will actually be an early evening for me if I get
Would
out
be.
before midnight. So.
I think you have the capacity to be here till 2 o'clock in the morning. So thank you. Let's, Mr. Mullen, do you want to pose you one question and we'll see where we go here?
I'm wondering if, given the situation with Route 28 and the need for the state highway access permit, when do you think it would be appropriate to consult the DOT regarding the study the issuance of the permit, the conditions on the permit, and the ability to take a left out of the site heading north, in particular.
Truthfully, it should have been done before the traffic study is prepared. I mean, really just in terms of, and they may have done that. They may have done that already, but given the fact that you need a state highway access permit, typically what you do is, at least during the preparation of the study, you're consulting with them, but certainly from the applicant's perspective, you would want to understand if there are going to be limitations put on the access, what those are going to be, and I think also importantly, what are the design standards that you're going to be held to, because again, from the applicant's perspective, once these plans are submitted to you, and if you do in fact approve them, you're approving the plans that are before you. And if changes need to be made because of the state highway permit process, it needs to come back to you. So you really didn't gain any time, because you'd have to reopen the public hearing to go through any changes on that. So truthfully, it should have been done prior to the preparation of the traffic study, so that we could see in the traffic study the consultation was made, and that what's being presented in here is something that the state has provided some guidance on.
Is that your one question?
I have a follow-up.
Good. Well, I had a follow-up too. You asked
Oh.
your follow-up.
Well, my point would be, that's a great answer, and I would like to begin to get some input from the Commonwealth on this issue, and I think it's important that we have it, and I don't know who's the next moving party on doing that, but I particularly from the district, that we have something to consider.
I have two questions. One is just a brief question to Mr. Casciano. Can we fairly assume that an application or preliminary meetings with MassDOT have not taken place? Is that fair to say?
I'm not sure. Yeah, just to,
Sure. Why don't you have to come up here to the microphone, Mr. Burke? Why don't you just introduce
We've,
yourself so the people will know
spoke
who you
with,
are.
well, haven't spoke with, we've contacted District 6 and submitted the plans. We haven't gotten any feedback yet, but they're pretty good about getting back. And I basically set the plans the plans that you're looking at, and asked for a meeting to go over it. So we're just waiting to hear.
Okay. Thank you. That was James Burke. Thank you, Jim. Let me ask you, Mr. Dirk, based upon your experience in dealing with MassDOT, is there a reasonable turnaround time when you should expect a well-reasoned response from the Commonwealth on that type of application, or at least preliminary inquiry?
But the consultation can happen quickly. It's just a matter of when the district personnel would be available to sit down and meet with you. So that's something that can be done depending on their schedule, basically. The state highway access permit process has statutory, they have standard operating procedure. And it sets timeline. So from the date that they submit a formal application, complete application, there's 10 days to review that application to determine that all the information is there. Then from that 10-day time period, there's another 30 days to complete the review. Within that time frame, at any point, they can issue a letter saying that they need more information, and then the clock starts over again. So it's 10 days to determine that they have the information, and then 30 days beyond that, they either need to say they need more information, or they act on it, or it's deemed approved, similar to...
It's constructively after 40 days. Okay, that's certainly helpful. Mrs. King, do you have any questions? I have no further questions. Mr. Casciano indicates that he and his colleagues have no questions. Mr. Whitten, sitting back there, do you? Thank you, Mr. Chairman. Okay, Mr. Whitten has no questions. Yes, Ms. O'Donnell, please. Yes, ma'am.
Kathleen O'Donnell from the town. The response to the letter that I sent to the board from Mintz 11, we had mentioned the fact that we felt that the driveway needed to have a left-hand turning lane because of the fact that cars would be queued up trying to turn onto Randolph to head north. And the response from Min11 was that they had done their traffic study, they felt there was no indication for a left-hand turning lane. Am I right in saying that you, when you reviewed their traffic study, they didn't factor into Pleasant Street? So that the people leaving that project in the morning, trying to get to the expressway or trying to get to Quincy or whatever, are gonna try to cross 4 lanes of traffic and and make a left to go to Pleasant Street. So then we hope that they've listened to you tonight and that they will be putting back into their traffic study an investigation of that Pleasant Street, because I do think that's going to probably have some impact on the queuing up.
Most definitely. I mean, the critical thing, we've agreed with the volume of traffic that the project's going to generate, but
Yeah.
as you said, that distribution of traffic is critical, because we need to know how many vehicles are going to be turning left. And we're looking at it and saying something didn't look right to us. They just need to explain it to us, or go back, revisit it, and revise the numbers one way or the other. But it's going to affect how the driveway operates potentially, and that volume of left turners. It could go up.
Yeah. Okay, great. Thank you.
Great, thank you, Ms. O'Donnell. And I see no other show of hands for a question to Mr. Dirk, so I want to thank you, Mr. Dirk, for
You're very
your
welcome. Thank
for
you.
your time and your excellent study. We appreciate it very much, and we look forward to the applicant getting back to you and getting your comments back to us. With no further ado, I think we're going to adjourn this meeting until March 31. Mary, it's at the account, March 31, 7:30 in the Council of Aging building where we are at the present time for the town's presentation. Thanks to everyone for your patience and your courtesy in staying so late. We apologize for the lateness of the hour. So we're adjourned.